What does it take to turn red-hot steel into perfectly formed heavy coils ready for the world's toughest demands? Step inside the powerful world of rolling, bending, cutting, and precision packaging, where raw strength meets cutting-edge technology to create industrial perfection. Plasma cutting is an advanced thermal process used to cut metal with high precision and speed. In this operation, a 3 mm thick steel sheet is automatically cut using a CNC plasma cutting system. The machine applied in this process is the RUR 3500 inches thermal cutting machine, designed for oxy-fuel, conventional plasma, and high-definition plasma cutting. The RUR 3500 is built with a fully welded machine frame, ensuring high structural rigidity and stability during operation. Its beam is completely welded without bolted joints, which increases durability and minimizes vibration. The machine is equipped with a digitally synchronized twin-side motion control system installed on both longitudinal rails. This guarantees smooth and precise movement along the cutting axis. In the cross-axis, linear bearings provide accurate guidance, while the new AC servo drive system allows cutting speeds up to 12,000 mm per minute. Digital synchronization in the longitudinal axis ensures balanced motion on both sides of the gantry. The system is controlled by the new Pierce 15-inch touchscreen control panel, offering user-friendly operation and precise parameter adjustment. During plasma cutting, the torch automatically senses the initial height of the steel plate. Arc voltage height control continuously adjusts the torch position to maintain optimal cutting distance. Electric ignition initiates the plasma arc, which generates extremely high temperatures to melt the metal. The molten material is then blown away by high-velocity gas, creating a clean and narrow cut. Floating cutting heads enhance accuracy when cutting uneven surfaces. Limit switch protection in each axis ensures operational safety. The machine also allows parking of one cutting head outside the working area when not in use. Optional equipment further improves performance. A 19-inch control system, higher speed servo drives up to 20,000 mm per minute, automatic gas console, anti-collision system, and plasma systems according to customer requirements can be integrated. Additional features such as pneumatic or plasma marking devices and portal frame air cooling support efficient and flexible steel cutting operations. The CSM 4-axis electric tube bending machine is an advanced hybrid CNC system designed for precision and flexibility in 3D tube forming. Developed by Addison Saws, the TDRE combines electric servo-driven bending on the C-axis and feeding on the Y-axis with hydraulic actuation for clamping, pressure die, and mandrel functions. This dual-stack, or two-stack, configuration allows the machine to perform two different bending radii within a single working cycle, increasing productivity and reducing setup time. A servo motor connected through a planetary transmission drives the bend arm, while another servo motor controls the carriage movement. Automatic mandrel lubrication ensures smooth operation and extended tooling life. The system is operated via an industrial PC with touchscreen control, 3D simulation capability, and USB connectivity for easy program management. The automatic ring bending machine is a specialized piece of equipment designed to support the production of metal spiral wound gaskets. As shown in the video Automatic Ring Bending Machine Installation and Commissioning, this machine is specifically developed for manufacturing and processing the inner and outer rings of metal spiral wound gaskets with high precision and efficiency. The machine is capable of producing rings with diameters ranging from 150 mm to 3,000 mm, a thickness of 3 mm, and widths from 6 mm to 40 mm. It is driven by a servo motor system, ensuring stable operation and accurate bending performance. All processing parameters are controlled through a touchscreen interface combined with a PLC control system. Operators simply enter the required dimensions digitally, allowing the machine to perform automatic bending and shaping. In addition, the equipment is fitted with an automatic cutting system, enabling fully automated operation. As a result, the processing speed is very fast and the finished products achieve a high qualification rate, ensuring consistent quality and productivity. Molten metal is first prepared by heating raw metallic materials in a high-temperature furnace until they reach a fully liquid state. Once the required temperature and composition are achieved, the molten metal is carefully poured into pre-designed molds that define the basic shapes of major lathe components, such as the bed, headstock housing, and other structural parts. The casting process ensures that the components have sufficient strength and rigidity for later machining. After solidification, the cast parts are removed from the molds and allowed to cool under controlled conditions to reduce internal stresses. Any excess material, such as runners and risers, is trimmed off, and the surfaces are cleaned to prepare the parts for machining. At this stage, the rough castings are visually inspected to ensure there are no major defects. The cast components are then transferred to machining workshops, where they undergo a series of precision machining operations. Using milling machines, boring machines, and grinding equipment, critical surfaces such as guideways, bearing seats, mounting faces, and alignment references are accurately machined. These operations ensure correct dimensions, flatness, and parallelism, which are essential for smooth and precise lathe operation. After machining is completed, individual parts are cleaned again and assembled into subassemblies, and then into the complete universal lathe. Mechanical elements such as spindles, gears, lead screws, and drive systems are fitted and adjusted to ensure proper movement and transmission. Finally, the fully assembled lathe undergoes a thorough inspection process. Dimensional accuracy, alignment, rotational accuracy, and operational stability are checked. Trial runs are performed to verify smooth operation, noise levels, and machining performance before the machine is approved as a finished product. HY100 is a high-strength alloy steel widely used in heavy industrial applications that demand exceptional mechanical performance and structural reliability. With a yield strength of 690 N per square millimeter, this material is engineered to withstand extreme stress conditions while maintaining toughness and resistance to cracking. It is frequently applied in shipbuilding, offshore structures, pressure vessels, and other heavy-duty engineering projects where both strength and durability are critical. In 4-roll hydraulic plate bending operations, HY100 steel plates can reach a thickness of 100 millimeters and a working length of approximately 3,100 millimeters. Due to its high yield strength, the bending equipment must provide substantial hydraulic force and structural rigidity. The top roll diameter of 600 millimeters ensures strong contact pressure and smooth force transmission during forming. Meanwhile, the side rolls, each measuring 530 millimeters in diameter, assist in guiding the plate into the desired curvature while maintaining stability. Pre-bending capacity of up to 65 millimeters allows the machine to eliminate flat ends before the main rolling phase begins. This feature is essential for producing complete cylindrical sections without unbent edges. In addition, the machine can also process thinner materials, such as 2 mm plates, demonstrating its versatility across different thickness ranges. Because HY100 steel has high resistance to deformation, precise roll positioning and pressure control are necessary to avoid excessive stress or cracking. The hydraulic system must be capable of delivering uniform force while compensating for springback. The combination of large roll diameters, powerful hydraulic cylinders, and accurate control systems enables efficient forming of this demanding alloy steel while preserving its structural integrity and dimensional accuracy. The 4-roll hydraulic plate bending machine is an advanced piece of industrial equipment specifically designed for forming high-strength materials such as HY100 alloy steel. With a yield strength of 690 N per square millimeter, this material demands exceptional power, precision, and rigidity from the bending system. The machine in this configuration handles plates 3,000 millimeters in length and up to 100 millimeters thick, requiring significant hydraulic force to achieve a bending diameter of 1,800 millimeters. This 4-roll design includes 1 upper roll, 1 lower roll, and 2 side rolls. The top roll acts as the main bending roll, while the lower roll functions as a feeding and clamping roll. The 2 side rolls provide the lateral force required to form the material into a precise curvature. The use of a swing system in this model increases bending efficiency by allowing the side rolls to move along a controlled arc path rather than a straight vertical motion. This creates a natural bending trajectory that follows the plate's deformation line, reducing stress concentration and improving the smoothness of the curve. The bending operation begins with the pre-bending phase, a crucial step that eliminates flat ends and ensures a continuous cylindrical shape. In this stage, the steel plate is inserted between the top and bottom rolls. Hydraulic clamping pressure secures the material, and one side roll moves upward to start the bending of one edge. By carefully adjusting the top roll's downward force and the side roll's position, the plate edge is bent to match the desired curvature radius. This operation is repeated on both ends of the plate to achieve complete pre-bending before full rolling. Once the pre-bending is completed, the operator proceeds with the rolling phase. The top roll exerts constant downward pressure, and the bottom roll rotates to feed the plate forward. The side rolls, controlled by independent hydraulic cylinders, move incrementally to guide the material's curvature. Throughout the process, hydraulic sensors continuously monitor the roll positions, pressure, and torque. The data is processed in real time by a programmable logic controller, ensuring the bending diameter remains precisely 1,800 millimeters. The hydraulic system of the four-roll press is designed for both power and precision. Each roll is driven by a dedicated hydraulic motor, enabling synchronized rotation and eliminating slippage. Central and side hydraulic supports stabilize the heavy steel plate during bending. These supports are especially important when working with 100 millimeters thick plates, preventing deflection and maintaining perfect alignment throughout the process. The system also compensates for springback, the natural tendency of the steel to return slightly to its original shape by applying controlled overbending. The swing system gives the machine a unique advantage over traditional three-roll benders. In conventional machines, side rolls move vertically, creating uneven stress and limited control near the edges. In contrast, the swing movement in this four-roll design allows smoother load distribution, greater mechanical leverage, and a reduction in required force. As a result, the machine can handle high-strength steels like HY100 with less energy consumption while achieving a consistent bending radius. During the bending process, the top roll, with a diameter of 600 millimeters, serves as the forming axis, pressing the material into shape while rotating. The side rolls, each 530 millimeters in diameter, move upward and inward to define the bending diameter. As the plate advances between the rolls, it gradually transforms from a flat sheet into a perfectly curved cylinder with a diameter of 1,800 millimeters. The bottom roll assists by clamping and propelling the plate forward, ensuring even pressure distribution along its entire length. To guarantee surface quality, all working rolls are induction hardened and ground to a fine surface finish. This prevents surface marks or damage on the material, especially important when working with high-value alloy steels. Lubrication systems continuously supply oil to the roll bearings and hydraulic components, reducing friction and extending machine life. Safety and control are integral to the system's design. The machine is equipped with an electronic control panel featuring digital readouts for roll positions, pressure, and bending angle. The operator can preset the desired diameter, in this case, 1,800 millimeters, and allow the PLC to automatically adjust roll movements and pressure levels. Emergency stop systems and safety barriers ensure safe operation even during high-pressure forming. After the rolling operation, the machine performs an automatic alignment and calibration cycle, checking the roundness and diameter uniformity of the finished cylinder. The hydraulic side supports then lower, and the rolled piece is removed either manually or with the assistance of lifting devices. The final cylinder exhibits perfect symmetry, accurate diameter, and minimal residual stress characteristics essential for components in shipbuilding, pressure vessel production, and heavy machinery. In summary, bending HY100 steel plates with a 4-roll hydraulic press is a process that combines massive hydraulic power with intelligent control. The machine's swing system, synchronized rolls, and hydraulic supports ensure precise, repeatable results even under extreme material resistance. Producing a perfect 1,800 millimeters bending diameter requires meticulous control of roll motion, pressure, and feed rate, all of which are handled automatically by the machine's advanced control system. This fusion of mechanical strength, hydraulic precision, and electronic intelligence makes the 4-roll hydraulic plate bending machine one of the most efficient and reliable tools in modern metal forming technology. St. 52 steel is a widely used structural steel, known for its balanced mechanical properties and excellent weldability. With a yield strength of 360 N per square millimeter, it offers good strength while remaining easier to form compared to high-strength alloys such as HY100. This makes ST52 particularly suitable for construction frameworks, storage tanks, pipelines, machine bases, and general industrial fabrication. In 4-roll hydraulic plate bending applications, ST52 steel plates can reach widths of up to 6,000 millimeters. The machine designed for this material has an overall length of 9,200 millimeters, a width of 2,200 millimeters, and a height of 2,310 millimeters, ensuring a rigid and stable structure capable of handling large plates. The bottom roll diameter is 440 millimeters, providing strong clamping force and smooth feeding motion. The top roll measures 470 millimeters in diameter, serving as the primary forming roll. The side rolls, each 360 millimeters in diameter, generate the lateral pressure required to create curvature. The bending process begins by positioning the steel plate between the top and bottom rolls. Hydraulic pressure clamps the plate securely, preventing slipping during operation. One side roll moves upward to initiate pre-bending on the leading edge. This step reduces flat sections at the plate ends and ensures uniform curvature during full rolling. After pre-bending, the bottom roll rotates to feed the plate forward, while the top roll applies constant downward pressure. The side rolls gradually adjust their positions to define the required radius. Because Street 52 has moderate yield strength, the machine requires less force compared to high-strength materials, but precise control remains essential to achieve dimensional accuracy. The 4-roll configuration allows continuous bending without removing the plate for repositioning. This improves productivity and reduces processing time. Hydraulic supports maintain alignment and prevent sagging across the wide plate surface. As the plate completes several passes through the rolls, it gradually forms into a cylindrical or conical shape with smooth surface quality. The final product exhibits consistent curvature, accurate diameter, and minimal residual stress, making ST52 steel ideal for large structural components. For applications involving extra-long plates, a 4-roll hydraulic bending machine with a working length of 500 millimeters provides the necessary capacity and structural rigidity. Machines of this size are commonly used in the production of large storage tanks, wind tower sections, silos, and heavy cylindrical structures. The extended working length requires reinforced machine frames and synchronized hydraulic systems to maintain uniform pressure distribution along the entire plate width. In this configuration, the machine is capable of pre-bending plates up to 10 millimeters thick and fully bending plates up to 12 millimeters thick. The rolls have a diameter of 460 millimeters, offering sufficient contact area to ensure smooth curvature formation. All rolls are induction hardened, which increases surface hardness and wear resistance. This treatment guarantees long service life and protects the plate surface from scratches or deformation during rolling. The bending process starts with hydraulic clamping between the top and bottom rolls. Pre-bending is carried out first to remove flat edges, allowing the plate to form a complete cylinder after rolling. The side rolls move precisely under hydraulic control to generate the required bending radius. Because of the long working length, maintaining alignment is critical. The hydraulic cylinders operate in synchronization to prevent uneven pressure, twisting, or deflection. Support systems beneath the plate help stabilize the material throughout the process. As the rolls rotate, the plate gradually transforms into a uniformly curved section with consistent diameter along its entire length. The combination of induction-hardened rolls, precise hydraulic control, and robust structural design ensures reliable performance even for oversized components. This type of four-roll bending machine offers high efficiency, accuracy, and durability in large-scale industrial production. The W12 four-roll plate bending machine is a robust mechanical device designed for the precise forming of metal sheets with both constant and variable curvature. It is widely used in metal fabrication industries where steel plates of a specified thickness must be bent into cylindrical, curved, rectangular, or other complex shapes with high dimensional accuracy. This machine operates on a four-roll configuration consisting of one upper roll, one lower roll, and two side rolls. The lower roll provides firm support to the metal plate, while the upper roll applies downward pressure to initiate bending. The two side rolls move independently to control the curvature and guide the material during the rolling process. This arrangement allows the machine to perform pre-bending, rolling, and final forming in a single setup, significantly reducing handling time and improving productivity. One of the key advantages of the W12 is its ability to handle both uniform cylindrical bending and variable radius forming. By adjusting the position and pressure of the side rolls, operators can produce cones, arcs, and non-standard profiles that are difficult to achieve with conventional three-roll machines. This flexibility makes the machine suitable for applications such as pressure vessels, tanks, structural components, and heavy machinery parts. The mechanical drive system ensures stable operation and consistent rolling force throughout the bending process. The rigid frame structure enhances overall strength and minimizes deformation under heavy loads, ensuring reliable performance even when processing thick metal plates. In addition, the four-roll design improves plate alignment, reduces slippage, and provides better control over the bending accuracy. Overall, the W12 four-roll plate bending machine is an efficient and versatile solution for industrial plate forming. Its capability to produce a wide range of shapes, combined with high precision and operational stability, makes it an essential piece of equipment in modern metalworking and fabrication workshops. The rolling of thick metal plates into cylindrical forms is a key operation in heavy fabrication industries, such as pressure vessel manufacturing, shipbuilding, and construction of large storage tanks. Using advanced Faxon rolling machines, flat plates of considerable size and strength can be shaped with precision into perfectly curved cylinders. These machines are designed to handle demanding requirements, with the capability of processing plates up to 120 millimeters in thickness and 3,000 millimeters in width, while achieving a minimum finish diameter of 400 millimeters. The process begins with the careful positioning of the metal plate on the machine's rollers. Hydraulic systems and precise controls ensure accurate alignment before rolling starts. The machine is equipped with multiple rolls, usually 3 or 4, which work together to gradually bend the plate. The central lower roll supports the plate, while the upper and side rolls apply controlled pressure to force the material into a curved profile. Adjustments to the roll positions allow operators to control the curvature radius, enabling the production of cylinders of different diameters within the machine's working limits. As the plate passes repeatedly through the rolls, it progressively takes on the desired cylindrical shape. For thick plates, several passes are usually required, with incremental bending in each cycle. The robust design of Faxon machines ensures uniform bending without introducing cracks or deformities, even when working with high-strength materials. Throughout the rolling process, operators monitor the plate's curvature and adjust the roll settings to maintain precision. Once the rolling is complete, the two edges of the plate come close together, forming a nearly closed cylinder. Depending on the final application, the edges may later be welded to produce a seamless structure capable of withstanding high pressure or heavy loads. The accuracy of the rolling operation is critical, as it ensures proper fit-up and reduces the need for corrective work during assembly. In conclusion, plate rolling with Faxon equipment combines power, precision, and efficiency. By accommodating plates of up to 120 millimeters thick and 3,000 millimeters wide, and rolling them into cylinders with a minimum diameter of 400 millimeters, these machines provide industries with reliable solutions for producing large, high-quality cylindrical components. The prepared steel plate is now transferred to the Heisler 3-roll bending machine. Using overhead cranes, the heavy plate is carefully positioned between the upper and lower rollers. Precise alignment is essential, because even a small deviation would affect the roundness of the final shell. Once the plate is centered, the machine clamps it firmly, and the rolling process can begin. The top roll presses the plate downward, while the two lower rolls move in a controlled manner, gradually forcing the steel to curve. Instead of bending the plate in a single pass, the Heisler system applies force progressively. With each rotation of the rolls, the curvature increases, allowing the thick steel to be shaped smoothly, without introducing internal stresses or distortions. For this operation, the plate is rolled until it reaches an outside diameter of 2 0.076 millimeters, forming a perfectly cylindrical shell. During rolling, the operator constantly monitors the plate position and the pressure applied by the rolls. Adjustments are made in real time to maintain uniform curvature along the full length of the shell. Because of the enormous forces involved, the rigidity of the machine and its foundation is crucial, ensuring that all bending energy is transferred directly into the steel. Once the desired diameter has been achieved, the rolled shell is carefully released from the machine and transferred to the welding station. Here, the longitudinal seam, where the two edges of the plate meet, is welded using the submerged arc welding process. This highly productive method is chosen for its deep penetration and high deposition rate. Two filler wires are fed simultaneously into the weld joint, allowing the seam to be filled rapidly while maintaining excellent mechanical strength. A layer of welding flux powder covers the molten weld pool, protecting it from oxidation and contamination. This also stabilizes the arc and improves weld quality. After solidification, the excess flux is collected and reused, making the process efficient and economical. The result is a strong, uniform weld seam that securely joins the shell into a single rigid cylinder. In addition to rolling, large steel plates are also shaped on a powerful press brake. A stainless steel plate measuring 60 millimeters in thickness and 7.2 meters in length is placed into the machine. With a bending capacity of 3,000 tons over 8 meters and a force of 800 tons per meter, the press brake applies controlled pressure along the plate, forming it into a precise radius. This process allows thick material to be curved accurately for special components that cannot be produced by rolling alone. The film then shows one of the most extreme forming operations. A steel plate weighing 43 tons with a thickness of 150 millimeters and a width of 230 millimeters is fed into the Heusler rolling machine. Because of its enormous stiffness, the plate requires multiple passes under massive pressure. Slowly, the rolls force the steel to curve until it reaches a final diameter of 5,000 millimeters. Each pass brings the plate closer to its final shape, while the operator carefully controls roll positions to ensure an even, circular geometry. Despite the extreme thickness and weight, the machine forms the plate smoothly without cracking or surface damage. The finished shell demonstrates the extraordinary forming capability of the Heusler 3-roll system, proving its ability to handle some of the heaviest and thickest steel plates used in modern industrial fabrication.